right? Can you guys hear me? Let me know in the comments before we progress. Let me know in the comment before we progress. Let me know in the comment before we progress. Let me know in the comment section before we progress. Let me know in the comments before we progress, guys, if you guys can hear me clearly. Let me know in the comments. Let me know in the comment section before we progress. Say I. Just let me know in the comment section before. Let me know in the comment section before progress, guys. Let me know. I'm waiting. I'm waiting for you guys. All right. All right. Let me know before we move further to start continuing the class. You know, the live just ended due to network problem. All right. So just let me know in the comment if you can hear me. So, guys, moving further, you can see we've talked about all of these things. As I was about saying when the live ended, the first one, you see it. I titled that chemistry 1. This is chemistry 2 now. You understand? So listen, in an exam condition, you can be asked. Remember I said that an atom has these 3 important subatomic particles called protons, electrons, and neutrons. And these subatomic particles, they all have their respective charges. For protons, they are positively charged. For electrons, they are negatively charged. For neutrons, they are neutral. An exam can just come, a question in chemistry can come, and they can ask you, all right, what is the, because if you observe, I did not tell us anything about the nucleus, the charge the nucleus has. But the question will now ask you, what is the charge for the nucleus of an atom? What will you tell your examiner? What will you tell the person that's going to mark you? What is the charge of the nucleus? Very simple. I will tell you the charge of the nucleus without any stress. You must note this. The nucleus of an atom is also positively charged. Why? This is because the nucleus is made up of a positively charged proton. Are you following me? If you observe, I know it has neutron, but neutron is neutral. So neutron being neutral does not amount or account for the charge of the nucleus. The only guy that accounts for the charge of the nucleus is the proton, because proton is positively charged, so the nucleus will take the charge of the proton to become positive as well. So the nucleus of an atom is also positively what? Charged. Are you there? The nucleus of an atom is also positively charged. The nucleus of an atom is also positively charged. Take note of that so we progress. Take note of that so we progress. Now, moving further, guys, you have to note this. You have to note this. You have to note this point. You must note here that this atom you are looking at, it has a mass. When we start calculating, you see what I'm talking about. This atom we are looking at, it has a mass. You must note this. You must note that the mass of an atom, the mass of this atom is concentrated in the nucleus. What did I say? The mass of this atom drawn and any other atom to be drawn. Where is the mass concentrated? Where is the mass found? That's the point. Concentrated means that where is it found more? The mass of every atom is found where? In the nucleus. I beg you note it. Because with this again, they will see action on that question. So you should note this. The mass of an atom is concentrated in the nucleus. The mass of an atom is where? Is concentrated where? In the nucleus of an atom. So an exam can also come and they will ask you this question. They can ask you this question. Let me write it here. Which subatomic particle. Which subatomic particle? Now, subatomic particle, they are also regarded to be called components of an atom. These three things, they are the subatomic particle. So, which subatomic particle contributes least to the mass of an atom? Contribute least to the mass of an atom. Now, I believe you know what least means. You now say, which of these subatomic particles, out of these three, which one of them does not really contribute to the mass of an atom? Because I told you guys that the mass is found in the nucleus. And remember, the nucleus has protons and neutrons. So now, they now ask which of them contribute least to the mass of an atom. Which of them does not have any business to do with the mass of an atom? Which of them does not have business to do with the mass of an atom? Let's say proton, let's say, let's call it ray of something. Now, so that's option A, option B, option. So guys, tell me in the comment section, which of them contribute least? Which one does not have any business? Because if you observe, because they told us that the mass of an atom is found here, and what is here is proton and neutron. So out of all these options, which one does not have any? Let's say this one, none. Let's just say none of the above. So which of them will not contribute least? Let me know in the comments. Let me know in the comments, guys. Very good, Keita. Very good. It is the electron. Why? Because electrons are not found in us. Remember, the mass is found in the nucleus, and inside the nucleus, we have protons and neutrons. You understand? So the question I say, which of them contribute least? It is the electron. Electron does not have business with nucleus. Are you guys following me? Electron doesn't have business with the nucleus of an atom. That is for that. So guys, let's move straight into the calculative aspect of this topic. Let's go straight into the calculative aspect of this topic. All right, we've learned some basic stuff. And also, you should know the discoverers. You should note here that electron was discovered by who? You should note that proton was discovered by who? Who discovered this? It was done by a man called Lord Ernest Rutherford. Whereby electron was discovered by a man called J.J. Thomson. Whereby neutron was discovered by a man called James Chadwick. James Chadwick discovered the neutron, whereby the nucleus was discovered by that same man that discovered proton, and it's still Lord Ernest Rutherford. Rutherford. Guys, ensure you note all this. So we'll go straight into the calculative aspect of this topic. Hope you guys are following me. Let me know in the comments. Hope you guys are following. Let me know in the comment section. Hope you guys are following. Let me know in the comment section. Hope you guys are following. Let me know in the comment section. Hope you guys are following. Let me know in the comment. All right, very good. So now I'm about wiping. So we'll go over to the calculative aspect of this topic. Let's solve. Let us solve. And the way we'll be solving step by step, because there are many diverse ways questions can come. All right, so you have to just notice. Remember, I represented an atom by drawing that cycle. An atom can also be represented by doing this as well. Drawing the symbol ox, and also here doing the same thing, ox. So let's say, for instance, this one that is ox, there is A here, and also here there is Z. This thing I just drew is also an atom. It's another way to describe an atom or to represent an atom. Now, I'm still going to do the same. A here and Z here. I know you are not surprised. Both of them, are they not the same? Yes, they are the same for now. But I'm going to alter this by writing plus or minus. So me writing plus or minus, you can see that it's not different from this. So first of all, let's leave this first and go over to this. Both of them are atoms, you understand? Just relax. This one that is A, it has a name. It is simply called what? Atomic mass. Remember, I told you guys that atoms, they have mass, and this is the mass. Atomic mass, that's what A is called. Take note. Now, if you don't call A atomic mass, you can call it another name. You can call it mass number. If you don't call A atomic mass, what will you call it? Mass number. And if you don't even call it mass number, you can call it nucleon number. If you check who, I did not say neutron or nucleus. I said neutron number. Neutron number. That's the other name for A. You understand? That's the other name for what? A. That's the other name for A. That's the other name for A, guys. So that is for that. That is for that. That is for that. So let's progress. Let us progress, guys. Let us progress. So now the question you ask yourself, what does Z means? What does Z mean? All right. Now Z has a name as well, and Z is simply called atomic number. Please take note. Atomic number is different from atomic mass, and if you don't call Z atomic number, you can simply call Z proton number. You can simply call Z what? Proton number. You can simply call Z proton what? Number. Now moving further, guys, the meaning of A and Z here is still the same. So what differentiates these two guys? Now, what did I say? What do you call it? I called both of them atoms, right? This guy is an atom. This guy is also an atom. But if you observe, this one does not have plus or minus, whereby this one has plus or minus. So this one that has plus or minus is telling me that, okay, well, this atom has a charge. So then, this atom, specifically, it is a charged atom. And there is a way we solve questions for charged atoms. Relax, I'm going to explain. And this one without no plus or minus, it is a neutral atom. And the goal of this live section is for us to be able to determine correctly the numbers of protons, electrons, and neutrons that are found in both types of atoms, being what do you call it? Be it is a neutral atom or a charged atom. That's the goal. That's the goal. So that's what we are going to, focus on. So please pay attention. Please pay attention. Please pay attention so we can progress. Pay attention so we can progress. Pay attention so we can progress. Now, moving further, guys, you can see here that the goal is for us to be able to determine the numbers of protons, electrons, and neutrons found in an atom. Same applies to this. We are still going to learn how to determine the numbers of protons, electrons, and neutrons that are found in this charged atom. But first of all, let's learn how to determine the numbers of protons, electrons, and neutrons found in neutral atoms. Then after learning this, we'll go over to this. Are you guys following me? So pay attention. Now listen, this proton, very easy. Proton number is if you observe, I think there's a proton number is same as atomic number. And what's the atomic number? It's not Z. So in calculation, proton number is Z. Let's say for instance, when we start solving questions and here is 11 for instance, what becomes our proton number? 11. So what exactly is here should be it should be the proton number. Are you following me? Now, moving forward, I believe you've understood how we calculated proton. Relax. Then, how do we go over to electron number? Very easy as well. To calculate electron number, you have to note this. This atom, is it not neutral? Yes, it is neutral.